Question number 7 ni, for A, they ask you to explain the effect of temperature on the electrical resistance of the metal. So to explain this one, you have to pick a formula. So from the question, if you read, once you read that there's involved a temperature, you only have one equation. No? So from equation, R equals to R naught, 1 plus alpha delta T, or T minus T naught. Okay, you can say that R is directly proportional to the temperature, or delta T. Okay, so if temperature increase, resistance will increase. Okay, for question B tu, soalan dia tu maybe ada typo. Okay. Rho is equals to 1.72 times 10 negative 8. How do you know that this one is rho? It's based on the unit itself. Okay, so the unit is ohm meter. So kalau ohm, dia ada resistance. Kalau ohm meter, that means rho lah. And then given that I is equals to 2.07 ampere, A is actually 8 times 10 negative 7. Nanti kamu tukar, nanti kamu kira balik, you should get the answer. And the length would be 50 meter. Okay, double check before you try to calculate whether all the units are the same. So everything here is in SI units, so okay lah, you can start to calculate. For the first question, they want you to calculate the resistance of wire. So you can do that by using rho equals to RA over L, right? So R is equals to rho L over A. Masukkan je nilai dia, you should get the answer. And the second question, they want to find the potential difference across the wire. This one pretty much straightforward lah. You can use V equals to IR. Again, this one based on the answer before lah. Kalau yang tadi jawapan kamu lari, and this one pun akan lari juga lah. And the third question, they ask you to find energy dissipated in 1 minute. Okay, this one you have to calculate. Basically, you want to use E equals to PT. Energy is equals to power times time. So power dissipated times time, you get energy. So to find this one, you have to use P equals to I square R. Okay? Find power first, and then once you get that one, you can apply the formula for E. Kamu buat cara ni kan, cuma jawapan dia tak sama, betul?
Betul.
Yang C tu nak bincang ke? Okay.
Yang C sir, bincang sir.
Okay, C pun nak buat. Okay, so we try. Tengok soalan mana. Okay, for question C, they give you a circuit. So normally, I would like to redraw lah. Ini kita nak buat masa, saya tak redraw. So, si 7C instead of redraw, saya pakai yang dah ada ni. Okay, so first thing first, you have to identify yang current 1, 2, 3 tu represent yang mana satu. Okay, that's the first thing yang you need to do lah. So maksudnya, kalau I1 tu saya label dengan yellow. Okay, kamu boleh warnakan lah. Okay. And then I2 kamu boleh pakai color green ni contohnya. And then I3, I can use the blue color here. Okay. And then after that you can label like loop 1 and loop 2. So this will be my loop 1 and this will be my loop 2. Okay. So before we start, actually how do you know that this one you have to apply Kirchhoff? Kenapa kamu nak apply Kirchhoff? Apa dia punya key things? Okay, pernah cakap sebelum ni?
More than 1 EMF.
More than 1 EMF. Okay, very good. Okay, correct. So if you have more than one, in this example we have 42 and 28. So immediately we know we have to apply Kirchhoff. So kadang-kadang student confused nak apply Kirchhoff ke nak apply series parallel. So that's the key things. Okay, after that normally we like to determine direction of current and loop. Tapi here the direction of current is already given. Okay, so you don't have to determine lah, kamu kena ikut je. Okay, loop direction, you can determine, macam saya selalu cakap, nak tentukan loop direction, you can always choose ataupun follow yang biggest EMF. So here is the biggest one between these two, right? This one is bigger. So we use that one as our guidance. So we start from the positive. So loop direction will be in that direction. We can do like a circle, but normally I do like squarish like this. Ya, ada student dia suka buat macam tu. Tak kisah, dia boleh. Yeah? So in this case, this is the loop lah. For the first loop, this is the loop direction. For the second loop, try to follow the first loop lah, especially yang kat tengah tu, so that you don't get confused. Okay, so you can see that yang middle part here, loop yang belah kiri tu going down. So loop on the right pun kita nak dia going down. Okay. Again, kalau kamu salah pilih direction, it doesn't really matter, you still get the answer. Cuma mungkin kamu akan banyak negative values. Itu je. So don't worry. So once you do that, basically you have to apply junction rule lah. So nak apply junction rule tu kamu kena tentukan junction dia kat mana. So here I choose this one. Okay, junction rule tu dia mesti summation of I in equals to summation of I n. Sorry, out. So maksudnya jumlah current yang masuk sama dengan jumlah current yang keluar. So dekat junction color orange ni, current mana yang masuk?
I1, I2.
Yes, I1 and I2. So it will be I1 plus I2 and then yang keluar tu adalah I3. Okay. So kalau kamu boleh masukkan nilai, let's say they give you I1, I2, I3, kamu masukkanlah sekarang ni. Okay, tapi sekarang ni dia tak beri. So you just label this one as your first formula. Okay. The next one, you want to apply loop rule. Okay, loop rule tu, sorry, second rule lah. Second rule, summation of EMF sama dengan summation of IR. Maksudnya total EMF sama dengan total yang across register. So kalau kamu tengok dekat first loop ni, loop yang ni, ada berapa banyak EMF?
Dua.
Ada berapa banyak resistor?
Dua.
Juga kan. So basically you will expect dekat sini ada dua term, dekat belah kanan pun ada dua term. Okay? So you just have to determine whether it's positive or negative. Okay, ingat pesan saya, kalau nak tentukan yang EMF ni, kamu tengok direction of loop dia. Loop dia ni naik ke atas. So keluar daripada positive terminal here. So dia adalah positive. So positive 42. Okay. And then untuk EMF juga, dia jalan-jalan, dia pergi sini. Okay, now the loop direction is going down. So kalau dekat sini, dia akan keluar daripada negative terminal. So it will be negative 28. Ini yang selalu student terlupa letak. Kalau kamu salah satu sign convention memang salah. So be careful. And then on the right hand side you have two resistor. You can start from here or here, tak kisah lah. Let's say we start from here. First of all you have to see where is the direction of current dekat situ. So current I2 tu kalau dekat bawah sini dia ke kanan kan. So maksud dekat sini sebenarnya dia ke bawah. Okay. So you can see loop direction upwards, current direction is downwards, so opposite direction. So IR kamu kena negatif. Okay. Kalau kamu label ni sebagai R1, R2, R3 ke, kamu boleh masukkan lah. Kalau tak label boleh terus masukkan 6 tu je. So maksudnya 6I2, then you should put negative. Kenapa negatif? Saya bilang sebab yang this one loop direction going up, current direction going down. Okay, and then you have another resistor in loop 1, which is this one. In this case, current direction yang I1 tu ke bawah, loop direction pun ke bawah, same direction, so it will be positive. So positive 5I1. Okay, jangan tertukar subscript jangan tertak dua pula, nanti salah lah. So dia jadi I1. Yang lalu tu dengan resistor dia tu nilai dia berapa. Okey, kalau boleh ringkaskan, kamu ringkaskan. In this case 42 tolak 28 tu boleh ringkaskan kan, kamu akan dapat 14 42 minus 28, yeah, should get 14. So 14 equals to negative 6 I2 plus 5 I1. So this is the second equation. You want to apply another times for second loop. So here second loop, you look carefully, covers from there up until here lah again. So for this part, dia ada satu EMF, dua resistor. So belah kiri tu ada satu nilai, belah kanan tu ada dua term. So belah kiri ni loop direction ni ke bawah, so dia keluar daripada negatif kan, negatif terminal tu, so dia negatif EMF, so negatif 28 lah. So negative 28 equals to, dia keluar kat sini, sorry, yang untuk yang kat sini loop direction downwards, current direction pun downwards, so same direction, positif lah, 5I1. And then for this part, loop direction going up, current direction kalau kamu follow yang I3 ni, dia akan naik atas juga. So dua-dua adalah positif. So dua-dua same direction, so positif lah. Plus, jadi 3I3. Okay, so far can you guys follow? Do you have any question?
No, sir.
Okay, so after this, basically you want to apply, you want to calculate using calculator. So make sure each one of you try to do it yourself. Okay, jangan take the answer for granted lah. So to do that, the best way is that you can rearrange all these three equations. Rearrange dia supaya bila kamu masukkan dia jadi mudah. Okay, ini kamu tak perlu tulis, tapi saya rapatkan dia so that kita boleh nampak lah apa yang kita ada. Okay. So normally saya skip yang part ni, I just rearrange straight away and then saya terus letak dia dalam appropriate macam position lah. So now if you want to apply the calculator, I think if you use yang color hitam tu, you have to apply, you have to press setup tu. Saya sebab tak ada calculator, saya tak ingat. Lepas kamu tekan arrow tu, kamu pergi ke page sampai yang A tu dari equation, betul tak? Lepas tu kamu tekan sama dengan, lepas tu kamu select simultaneous equation. Ini unknown tu kamu ambil 3. So kamu ada I1, I2, I3. Boleh ke tidak? Adakah kamu semua sedang menekan?
Boleh sir.
Boleh, nanti dia keluar macam matrix kan. So dalam matrix tu kamu akan nampak macam I1, I2, tapi dia tulis X, Y, Z lah. So dia ada X, Y, Z sama dengan, lepas tu satu lagi tu tak ada constant. Satu lagi tu hanyalah nombor, dia tak ada apa tu variable. So maksudnya kalau saya nak tulis nombor ni, saya akan tulis yang I1, I2, I3 and then sama dengan any number yang tak ada I. Saya A contohnya. Okay, so basically kalau yang equation 1 tu saya rearrange, dia jadi 1I1 tambah 1I2, I3 tu belah kanan, so saya bawa ke kiri, tolak 1I3. Satu tu tak perlu tulis, saya tulis sebab takut tertinggal nak tekan nanti. So A ni sama dengan kosong lah untuk equation 1. Kalau untuk equation 2, A tu adalah 14. Okay. So I1 tu saya letakkan dia ke depan. So 5I1 minus 6I2 minus 0. And then the third equation, negative 28 and then 5I1 plus 0I2 and then plus 3I3. Okay. So now you just have to key in. So macam contohnya yang pertama tu 1, 1, negative 1, 0. Okay, and then kamu boleh follow lah. Dapat tak? Berapa dapat?
Sir, ni tekan kalkulator je, sir.
Tinggalkan kita je. Kamu tak perlu kira satu-satu pun. Masukkan nilai-nilai tu sama. Nanti kamu akan dapat X, Y, Z tu. X, Y, Z tu akan represent I1, I2 dengan I3. So kalau ada negatif ke apa, kamu ambil je nilai tu, letak je dalam.
I1 tu negative 2,
Negatif 2,
I2 4A,
4A,
lepas tu I3 negative 6A.
negatif 6A. Okay, semua dapat jawapan sama ke?
Sama sir.
Sama sir.
Okay. So make sure setiap daripada kamu try untuk tekan ni sendiri. Okay, jangan ambil jawapan kawan-kamu ni lah. Sebab apa? It's really important for you guys to try to do it yourself at least sekali lah. Baik kali lagi bagus lah. Dah jalan exam, nak tekan macam mana? Yang kedua, yang second tu saya dapat negatif 4 juga. Betul tak? Nanti kamu check balik Kalau dapat negatif 4. Okay. Salah tengok kot. Okay, anyway. Negative here means that the direction of current actually opposite daripada yang initial assumption. So maksudnya kan, initial assumption kamu ikut yang soalan kasih kan. Contohnya I3 ni ke kanan, so sebenarnya I3 tu ke kiri. Mana tahu dia tanya current direction dekat dalam resistor tu, so you can answer yang dia adalah going downwards lah yang sebenarnya. Jarang tanya lah, mungkin tak impossible tu ditanya. Okay, so pembahagian markah for this kind of question. Final answer ni dia kasih jawapan dengan unit dia betul, dapat 1 markah setiap satu ni. So tekan kalkulator tadi tu dia dah 3 markah. Okay. And then penggantian over here, you should get 1 mark. Gantian 1 markah, gantian 1 markah, dan gantian 1 markah. Okay, kadang-kadang dia kasih extra, dia kasih kat konsep ni. Macam like this one, dia kasih konsep. So biasanya markah dia dalam 6. Kalau lebih, dekat situ lah dia tambah. So 6, lots of marks. Kalau kamu bayangkan lupa letak negatif dekat sini, apa jadi kan? So you lose lots of marks. So kalau untuk Kirchhoff ni, buat slow-slow, relax buat satu-satu, step by step, and then you should get the answer correctly. Okay. Any question regarding this one? Regarding this question? Ada nak tanya tak?
Tak ada sir.
Tak ada.
No, sir.
Kalau tak ada, kita move on to the next one. Soalan seterusnya yang kamu tanya tadi, soalan 6. Okay, untuk soalan yang first ni, dia kata yang A1 tu, you are question 6. You are given several 1 kilo ohm resistor. How do you connect the resistor to circuit that require 5 ohm resistors? Shows the suggestion. Okay, so kalau kamu ada resistor, nilai dia tu lagi besar daripada yang kamu nak, the only way kamu nak kurangkan dia is by position the resistor in parallel. Itu je cara dia. Sebab sebenarnya kalau kamu nak ni, kamu kena letak di parallel. Kalau tak, memang kamu tak. Kalau series, kamu akan sentiasa dapat dia lagi besar lah. Okay. Dan in this case, kalau tengok sekali lalu tu nampak macam letak 2 je cukup. Sebab dia bagi, dia kata balik, dia jadi half. So dia, cuba kita kira. Cara nak buktikan, you have to show lah. So let's say R1 and R2 is 1 kilo ohm, so benda sama lah. So here R effective. Apa pakai R equivalent ke R effective? So jadi 2 over R kan. So 2 over 1 kilo, which is 1000. 1 over R effective. So 1000 divided by 2, you get 500 ohm. Okay, that was for question A1. Question A2 ni, dia kata kalau emitter tu ada internal resistance of 5, what is the reading shown by emitter? So basically kat sini dia jadi ada 5. So dia nak cari nilai emitter tu. So basically dia nak current yang dekat sini. Dari sini pakai Kirchhoff juga ni, sama je. Okay, boleh je kot apply balik. Ternyata macam straightforward je. Dapat ke tidak kalau yang dah cuba buat?
Dapat saya.
Nampak ya? Kita try tengok, kita try go through sekali lalu lah. If you want to go through one, first loop tu kamu kalikan. Sorry. Yang I1 tu kamu kalikan. I2 yang bawah sini. Dan then kamu ada I3 ataupun IA tu lah, yang tengah-tengah tu. Okay. So, yang atasnya adalah loop 1, bawah tu adalah loop 2. Next, we determine the loop direction ikut EMF yang paling besar, which is yang 3 tu. So, loop direction will be in that direction. Kalau yang ni, ikut juga yang dekat tengah tu. So, in a way, dia akan jadi macam tu lah. Okay. Once you do that, kamu tentukan junction dia. Let's say kita ambil dekat sini. So, first equation kita akan apply I in sama I out tu. Okay, yang masuk adalah IA, yang keluar, yang masuk adalah IA dengan I1, yang keluar adalah I2. So, IA tambah I1 equals to I2. This will be your first equation. The second equation, loop 1. So, loop 1 ni kamu ada satu EMF. Ni EMF dia saja nak baca je. Itu je. So, satu EMF ada dua resistor. 3 dengan 5 tu. So, yang ni dua ni negatif sebab dia keluar daripada negatif terminal. So, negatif 2. So, negatif 2. R tu ada 2. So, lebih 3. Kan, kalau ini current dia ke atas sebab ikut current yang 1 ni. So, current dia naik atas, loop direction ke bawah. So, ini adalah negatif 3 I1. Okay. Dan yang second resistor yang 5 tu, IA, so 5 IA. Positif sebab current direction dia yang IA ni ke kiri, loop direction pun ke kiri, so same direction lah, 5 IA. So, tambah 5 IA. Okay, I just slowly double check ya, sebab saya takut tersalah buat. Saya cakap lah, if you do Kirchhoff ni, you really have to do it slowly. And then the last loop tu, second loop tu, you have one power supply, so 1 EMF, and that one is positive 3. Lepas tu dia pass through 5 ni, current to the left, loop direction to the left, so it becomes 5 AIA. Dan dekat sini, loop direction downwards, current direction bawah juga, so positif juga lah. So you have positive 3 sama dengan positif 5 IA. And then 2 I2. Okay, this one is your third equation. So kamu rearrange and then you can solve lah. I1, I2, I3 terus sama I3 jadi IA lah. So tekan calculator, you should get the answer. Okay. So IA here sepatutnya dapat 0.16. Rearrange dulu. Lepas tu baru tekan calculator. Okay, saya tak buat lah ini. Sama je tadi. Okay, ada soalan lain? Untuk soalan nombor 6 tu.
Sir. Boleh tunjuk ni tak yang soalan 6B2 tu?
6B2. Okay. 6B. Okay. 6B2. Oh, this one. Okay, 6B ni soalan ni pasal apa?
Potentiometer.
Yes, potentiometer. So, biasanya kalau macam ni, saya akan suruh selesaikan gunakan kabel. Okay, we try to do soalan yang satu tu dulu, 6B1. Okay, kata what is the length of SP when the galvanometer reading is 0? So, nak selesai ni senang je. Pertama sekali, kalau saya lah, dan exam saya akan lukis balik circuit tu, kena saya label dekat circuit tu lah. Contohnya, dia kata, the length of the wire XY tu adalah 100 cm. So, this part adalah 100 cm. The resistance is 5 ohm. Okay, untuk panjang 100 meter tu, resistance adalah 5 ohm. The EMF of cell A and cell B is 4 and 3. So, this one will be 4 volt. This one is 3 volt. The internal resistance for both cells are negligible. With the length of XP when the galvanometer reading is 0. So, nak cari panjang XP tu. Macam biasa, saya akan lukis table. So, table dia consists of V, R, L. So, V, R and then L. Okay. Lepas tu belah kiri ni dia akan ada driver. Oops. Lepas tu bawah dia ada X, Y yang panjang terus tu dengan yang kita nak cari lah, XP. Okay. Memang macam ni je cara dia. So, okay, kamu tahu kembali, kamu buat cepat sikit kot. V, R dengan L. Yang first tu, kamu padam dulu. Padam lah, potong. Okay. Okay, driver tu, part yang driver tu adalah first loop tu. The whole loop. Okay. That whole loop, voltage dia adalah berapa? Dekat loop satu tu, voltage dia berapa? Sini.
4.
4 kan? Dia punya resistance? Resistance.
5 sir.
Kalau kamu tengok, betul ni. Kalau kamu tengok dekat sini saja, cuba juga. Kalau kamu tengok dekat sini saja, dia tak ada apa-apa tau. So kalau ada apa-apa, kamu kena tambahlah dengan dekat sini. So kalau tak ada apa-apa, so basically resistance yang ada hanya dekat X, Y je untuk first loop tu. Dekat sini lah. So itu adalah 5. So 5 lah. Kalau dekat atas tu ada kecil lagi satu, sini ada 1, dia jadi 6. Kita tak ada kan? So 5. So 5 ohm. Okay, panjang. So voltage XY kita tak ada lagi. Resistance XY kebetulan dia samalah sebab dia tak ada resistor lain. Ignore kan. Dan length of XY adalah 100 cm. You can use cm and then find the answer nanti dengan cm jugalah. Lepas tu kita nak cari panjang XP tu. We want to find this one, LXP. Okay. VXP sebenarnya kamu ada sebab apa? Dia kata ini adalah 3. So maksudnya kalau kamu punya ni 3, dia punya kat sini pun 3 juga. 3 volts. Okay, barulah dia apa tu? Galvanometer reading baru jadi 0. So ada potential dia sama. Okay, so to do this, maybe the first step you can find voltage untuk XY. Okay, so to find that, I can combine yang part ni lah. Okay, so I can use VXY over 4 equals to 5 over 5. So my VXY sebenarnya adalah 4. Okay, saya rasa macam tak perlu lah kira benda ni sebab dia benda sama. Okay, so 4 volt. Tak apalah, now confirm lah 4. And then the next one, you can apply the second step tu. Basically you can apply this one, VXY dengan 3 volt tu, and then you can combine this one. So kamu nak cek LXP tu. So LXP over 100, XP over 100 equals to 3 over VXY tu dia adalah 4. Okay, 100 bagi 4, 25, 3, 75 cm.
75.
Okay, very good. Okay, ini untuk first step. Okay. So obviously you can try to solve ni without using the table pun boleh. Tapi kalau bagi saya prefer pakai table lah. Just copy everything. Then try to do the next question. Dan dua tu. Okey, soalan 2 tu apa yang berubah sebenarnya adalah dia kata now 1 ohm resistor is connected in series with cell. So over here dia ada 1 ohm.
Ditambah.
So dia akan tadi kan, kalau macam yang tadi XY ni adalah 5 ohm. Okay. So dia tambah kat situ ada 1. So maksudnya dekat sini, kat driver ni yang berubah. So driver dia tadi 5 saja, now dia kena buat 6. 5 tambah 1 lah. So bila itu berubah, VXY kamu akan berubah juga. Bila VXY berubah, kamu punya final answer pun berubah juga. Okay, let's try to calculate. So VXY over 4 sama dengan 5 over 6. Tadi 5 over 5, nak 5 over 6. So 2, 3, 10, 3, 3.333 volt. Betul tak? Check.
Betul.
Betul. Okay, once you get that one, you can solve ASP tu. ASP over 100 sama dengan 3 over 3.33 volt. This one I got is 90.09. Betul? Okay. So itu beza dia. Okay. Kalau buat table, senang lah, bagi saya senang tapi dia kamu kena lukis lah tu betul. Yang penting maklumat kamu keluarkan tu kena betul. Okay, that one is for question 6. Next question, we try to work question number 4. 4. Okay, 4 yang C tu saya rasa tak ada masalah. Sebab, 4C tu sebenarnya soalan dia tu tak cukup maklumat. Porsi tu sepatutnya ada satu maklumat di atas ni adalah berapa tu dia betul. Chapter 3. Nilai kat atas tu adalah 16 ohm. Okey, sepatutnya kat sini adalah 16 ohm. Okay. So ini pun Kirchhoff juga. So I think tak ada masalah kot. Kalau kamu dah buat, kamu dah masukkan 16 ohm tu sepatutnya boleh selesaikan. Nanti cuba balik. Saya tak bincang lah yang ni. Tunggu sikit. Okay. Ini adalah 16 ohm. Okay, and then yang soalan lain itu 4A. Yang 4C tadi kamu cuba buat dulu. Okay, katakanlah kamu still tak dapat by minus A, nanti kamu tanya saya balik. Yang tu saya sedang masalah lah. Jadi kita dah bincang lah. 4A ni kata show some of the free electron inside the sides of section of a cylindrical copper wire. Okay, the wire is connected to an EMF source and the direction of the electric field E is indicated as in the figure. And then the wire, okay, sketch a diagram to show the motion of one free electron, the direction of drift velocity and the current. So mungkin kamu boleh lukis balik. So you can try to redraw A1. Okay. Boleh lah. Okay, so you have this one electron. This is sebut pasal electron je. Okay, dia kata direction of electric field is to the right. Kalau electric field to the right, kamu tahu yang kat sini sebenarnya adalah positif, sini adalah negatif. Sebab electric field memang dia keluar daripada positif, dia pergi ke negatif. So if you have an electron, it goes towards the positive terminal. Biasalah ke kiri. So the drift velocity direction will be in this direction. So kita panggil ni sebagai V drift. Ni V drift ni ibarat V average. Okay. Tapi itu the direction of V drift. Tapi the actual motion, saya baca sketch diagram to show the motion of one field electron, the direction of drift velocity and the current. Okay. The actual motion is sebenarnya more like a zigzag. Okay. Tapi secara average dia akan pergi towards there. Faham ke tidak? And then they also ask you to indicate the direction of current. So kalau elektron ke kiri, direction of current ke mana? Kiri ke kanan? Nice. Electron to the left. Current would be?
Right.
Yes, to the right. Very good. Okay. Macam terminal battery lah. Positive. Current flows from positive to negative. But the electron flows from negative to positive. So current direction is to the right. Do this and then you should get about 2 marks for soalan macam ni. Okay, and then the next question dia kata yang A tu dia kata if the current in the wire is 50 milliamps, so that one is your I. Calculate the numbers of electron passing a point in 10 seconds. Okay, so if you go through the formula sheet, you will see that you have a formula of I equals to dq over dt. Ni from the definition, rate of change of charge over time is equals to current. But kalau kamu punya change of charge tu adalah constant ataupun dia tak berubah-ubah, kamu boleh tulis sebagai Q over T equals to I untuk average. Okay. So you can calculate the numbers of charge first, magnitude of charge first, which is I T. So 50 times 10 negative 3 multiply with 10 seconds, you should get 50 times 10 negative 2 coulomb. Okay. Once you got this one, you can calculate dia punya E dia tu. You know that Q sama dengan N over E. Sorry, Q equals to N multiplied by E. E tu elementary charge, darab dengan numbers of electron, sama dengan total charge. So, kita nak cari N, Q over E. Okay, this one you should get 3.12, 3.13 lah. 3.13 times 10 to the power of 18 numbers of electrons. Okay, for question number 2B ni, they give you a circuit and then in this circuit consists of two power supply here lah, 2 MF. So straight away you know that you have to apply Kirchhoff rules even though it's just only one loop. So to do that, maybe I can try to redraw the circuit because basically I want to take out the internal resistance there, okay? So that I don't miss it. So if I do that, I have 8 ohm over there, power supply over there, the internal resistance, the resistor, another resistor there, another internal resistance over here, and then power supply EMF. Okay, so here you have 8 ohm, and then you have positive, negative terminal, oops, and then you have internal resistance, another resistor there, okay, and it should look something like this. Okay, this one is 6 volt, this one is 1 ohm, that one is 12 ohm, and this one is 9 ohm, and this would be 10 and 2 ohm. Okay, and then they give you 4 points, A, C, B, and D. The first question, they want to calculate the current that flows through the 8 ohms resistor. So this one, so because you only have one loop, so everything are in series, so you only have one values for current. So basically as long as you calculate the current, then it will be the current that passing through the 8 ohm resistor. So to solve this one, you can apply, the loop direction is given in that direction. we can apply the second rule straight away. It's about first rule, we don't have any junction, so you can apply that one. So summation of EMF equals to summation of IR. Okay, but before that you have to apply, or you have to determine the current direction. And if you want everything to be positive, then you choose the current direction to be in the same direction with the loop direction. Okay, then you will have a positive current IR too. Okay, so here we have, for the first one, it's positive 6 volt and then positive 10 volt. So positive 6 plus positive 10, because the loop direction going out from the positive terminal. And while passing through the resistor, here you have 8I, 2I, 9I, 12I, 1I. Everything is positive because loop and current direction are the same. 8I plus 2I plus 9I plus 12I and then 1I. So total you should have 8, 10, 19, 20, 32. Okay. So your I is basically 16 divided by 32, which is equals to 0.5. Okay. And this is the current that will be passing through the 8 ohms resistor here. Okay, for the second question, basically the question wants you to find the potential difference across point A and point C. So you can determine by using, you can use two directions. You can flow from A to C, or you can use this direction like that. Okay, so both answer will have the same magnitude, but one will have a negative, another one is positive values. Okay, we try to look at this both method. So if you use one delta V between A and C, if you use the further distance there, so basically every time it goes through the resistor, it will be negative voltage, potential drop. It goes through power supply or EMF, it will increase in potential gain. So the idea is that the whole loop, let's say start from A, right, and when it ends at A, we get 0. Okay, the whole loop lah. That's the idea. Okay, anyway, and this time for the first resistor you have 8 ohms, so I have 8I. Okay, this one will be negative because potential drop, and then 2I negative as well because potential drop. Potential gain over here positive 10, and then I have potential drop over there negative 9I, negative 12I. That's it. Okay, so you stop over there. So now you have 8 plus 2, 10, negative 10, negative 22, negative 31. I just recheck this one. 8 plus 2 plus 9 plus 12, negative 31. I is equals to 0.5 plus 10. So I got here is negative 5.5 volt. Okay, and then if I use the shorter distance there, delta VAC, let's say I just flow from here to here, so it goes through the potential gain there, which is positive 6, okay, and then drop at 1, 0.5. So this time you get 5.5. You have the same magnitude, just that one you have positive and the other one is negative. Both answers are correct. So I can write down that VAC is basically the magnitude. Magnitude is equals to 5.5 volt.